Hey, good morning, everyone, or afternoon almost. Testing this guy. Followed by some hash, some concentrates, like five. That printer. Let's shoot that one. Okay. We'll get started here in just a few minutes. Got to print off some labels for these vials. So, let's see what we're going to do here. All right. So I think what we'll do is we're just going to go ahead and get started on testing these. So, we'll start with the flower sample. It smells pretty good for being a year old. All right, I'm going to show this to you. It's a nice size sample. Definitely more than you need when you're mailing yours in, by the way. All right, so for this guy, we're just going to take a little sample. And what I'm going to do here is just kind of grab pieces from all around it, since it's kind of letting me. And then we're going to weigh it. Alright, so this is going to be way too much material. You can see what I have here so far. It's way too much. So I'm just going to break this down into more pieces, and then I'm going to randomly select which ones are going to make it to the weighing. Alright, so I think we're going to go with that. That's probably still too much material, but we'll see. Alright, so that was too much. This is what we're going with. This is 95.4 milligrams. Dropping shit everywhere. So 95.4 is what we're going with. .4. Alright, so take one of these vials. And that's it. Alright, so I'm going to label this vial here. Next thing I need to do is add solvent, but I'm going to do something a little different than what I normally do. And I'm going to weigh the solvent in the bottle. Flour. The reason I'm going to weigh the solvent in the bottle and make note of the weight here is I'm going to use the weight of the acetone to basically backwards calculate exactly how much solvent made it into the vial. So that's what I'm going to do next. So the way to do that, simply going to tear this first, grab my solvent dispenser, dispense, weigh it again, make note of the weigh the measurement, and I'll be back. So that's 9.2151 grams of solvent. 9.2151. Don't want to forget that. So 9.2151. All right. Want to make sure these are dry before they go into the next step. Otherwise, I might lose my labels, and that would be unfortunate. So 9.2151 grams for solvent, 95.4 milligrams of flour is our sample. And we're going to go ahead and do the next one here. So I don't have a way of denoting these because I don't know how fill distinguishes them. So this is what I'm going to do. I'm going to take one of these little labels I'm going to put on the top here. There's a 10x and a 20x. So I don't exactly know what the difference is necessarily just yet, but we'll note them as 10x and 20x. That one's a little sticky. That's all right. Got wipes around here somewhere. Hopefully. It's also why I use gloves in the lab. All right, so we're going to do that. And then we got this hash. And I forget what he said this was. Some kind of hash too, I think. Or it's like the last bits. So we will go ahead and I guess we'll start with the 10x. So I'm going to do that now. Alright, so again, when we do concentrates, going to take this vial, tear it first, take a toothpick or my handy fancy cannabis extractor. Going to take a toothpick and then put some in there. So get this weighed first. Alright, so this is going to be the 10x. Again, don't actually know what the hell this one is. But now, I'm going to go ahead and take my sample out of here. Just a small amount. Don't need a whole lot. If you can see that, that'll be more than enough. Alright, so that's in there now. Got to weigh this again. Alright, so that's 26.3 milligrams of the 10. Don't have any name for this. So 26.3. Just going to note that on our forms here, which I moved in front of me. So that's 26.3 milligrams. 26.3 milligrams of concentrate in this jar. We're going to tear the jar, add solvent, weigh it again. Alright, so that's going to be 9.4624. 94624. So 9.4624. That's the weight on the solvent into this jar, which is interesting to me because it did look like it was going to be less actually when it dispensed. But in fact, it dispensed more. So, because the last one was 92151. All right. Same process for number 20. I'm going to go tear this guy. Grab a toothpick. Can't use the other one. That'd be cross-contamination. Some of these are really sticky. So I'm just going to grab a little bit of mixture out of here. Okay. Just enough to be able to get some in my vial here. Okay. Can't even see that, I'm sure. But it's in there. So this is the 20. Oh, I didn't write the other one. The other one was the 10X. For lack of better name, this is going to be the 20X. So I'm going to weigh this now, and then solvent, and then weigh it, and then solvent. All right, second one's in there. So like the, third one. So like the second one, the solvent weight is higher than it was on the first. So, good to know. Good to know. So, 9.4613, that's what we got on the third vial here, which will be the second vial of concentrate. Alright, so just note that this is the 20X, and that's 9.4613 for solvent volume. Alright, fourth one, which is going to be this pressed hash. Same process. This one's a little easier because I don't need to use a toothpick usually. Very crumbly hash. Just gonna go ahead and take a piece out of there. Show it to you. So there's the hash. It's got a nice smell. This is way too much, by the way. So out of this piece, I'm just gonna break it down a little bit, and then I'm gonna go for a little pinch out of there, and we'll weigh it. So the weight on that is 39.1. 9.1. I'll get the solvent weight. So 9.4772. 9.4772. That's going to be our solvent weight. So 9.4772. This is our hash. All right. Get this label on the vial. Down to the very last one. Gonna be this guy. So I'll tear this. I don't know if you can see that. Probably not. It's a little dark. Indeed, it is very dark. Just trying to grab a pinch here so I can put it in this vial. That's probably enough. So that's going to be a 25.5 on the sample weight. 25.5. And we'll get the solvent. So 3695. So what we got going on over here. Alright. So now clean up a little bit, and then we'll get to the next part, which is testing. All right. Best I can. All right. That's over there. All right, so now that we have taken all of our samples, we've weighed them, added a measured amount of solvent. Now we're going to extract the cannabis out of whatever material's in here, and we're going to do that with the assistance of an ultrasonic bath, which I'm going to do now. So there's these. Take about 10 minutes. All right. So those are going. Now the next thing to do is figure out how much solvent is in these. So 1.365. So to do that, we're going to find an online calculator. So the screen will probably go off for a minute. I'll be right back. All right, so that's interesting to me. So one of the weights that I remembered was 9.365 grams. So I plugged that into aquacalc.com. I think is what it is. It's got all kinds of different compounds that you can do, weight and stuff. Anyway, so it comes out as 11.94 milliliters, just about 12. That's pretty cool. That's pretty darn cool. However, if I recall, we had one that was 9.1 and then one that was like 9.46. So there's definitely variation in the measures, and that's causing problems, probably. Or it could potentially cause problems for accuracy. So the ultrasonic bath is going to go. Um, After the ultrasonic bath, all but the flour sample are going to get diluted 20 times. So we'll do that next. And then those will go into, that'll go into the testing software, and we'll start running them. So here, coming up quickly. My standard looks healthy. The standard does not look as healthy. So we get 2 milliliters off. So if you watched last Wednesday when I made these reference standards, unfortunately I forgot to put this one away. However, fortunately it's cold and it didn't seem to evaporate, so got very fortunate there. So we'll use this to redo our calibration standard. We'll do a 3-point standard. At least 3 points, maybe more. But we'll do at least a 3-point standard. And then those will be done by then, and then we'll just get to run it off. Yeah, that'll be good. So I'm going to go ahead and make a 3-point standard right now. And what this is going to allow me to do, when you have 1 point of reference, you can't really judge that against anything. Even when you have 2 points of reference, you can't really judge that against anything. So to have a course, to have a direction, to have a line going somewhere, you need 3 points. And that's what we're going to do with our 3-point standard here. This is 125 parts per million. All right. I don't want to screw this up. That will make me sad. So the way that I'm going to do this, got to get my pipette. Alright, so I'm going to have to do this in 2 sequences. Just going to get this out of the way before I screw up and use it. So we're going to take the 125 part per million reference standard we have. And then we're going to take solvent to dilute it into a half. So it's going to be 62.5 parts per million. And once it's 62 parts per million, we'll do a 10x dilution on that to get it down to 6. So we'll have 6.25 parts per million, 62.5 parts per million, and then 125 parts per million. So we're going to do this, and then we're going to do a 10x on this. That'll be 400. That'll be what I need. I need to get half of that out of there. I need to do at least 20. Rule 2.5 plus 80 would be 100. Would be a 10x solution on that. Alright, so that's going to be 3 points, 125, 62.5, and 6.25. That'll be the lowest end. Alright, so at the 125, I'm going to take 200 microliters out of here, put it with 200 microliters in there, followed by 200 microliters of solvent. Putting these little glass vial inserts into this. Alright. So now we're going to take 120. Yeah, so I'll do one. I'm going to take 100 out of there into there, 200 into there. Alright, so if you're following along, I'm going to take 100 microliters out of this 125 part per million reference standard. There's 100. Boom. And I'm going to take 200 out of here. There's the first 100. All right, that's it. That's all I got out of this vial. Okay. My reference standard is gone. So now I'm going to cap these guys. Nothing happens to it. All right, so we've got 125. That's this guy. 1, 2, 5. Great. And then this is going to be exactly half that. Actually, I don't want to say I screwed up, but I needed to put one of these not into a tube, and then I could take it back out and put it back into a tube. So let's see if we can do that without screwing up too bad. This, by the way, unfortunate for it to work out this way. Yep, just lost some. Well, whatever this is no longer accurate. That sucks. That's really frustrating. Today is going to be a very frustrating experience, I can tell. It's already shaken up. It's already shaken up to be. Alright, so what's the best way to recover from this? Alright. So there's got 100 milliliters of solvent in there. That's fine. I should not have done what I just did, but I wasn't paying attention. Because that's how today is going to go. Alright, so we have ready to go, 125 part per million. Now diluted this guy to being half of that, and there's only 200 parts. There's only 200 microliters in here, so there's not going to be enough to do a secondary extraction. Well, I guess I could. So what I'm going to end up doing, I guess, is take So I'm going to take, there's 200 in here, I'll take half of this. Actually, if I take just 20 milliliters out of here and then put the rest in with the other one. Alright, we'll do that. Okay, sauna vortexing is next. I'm going to write on here what this is. 62. 62.5. Yeah, am I telling you, is just today gonna be fucking... Why? All my labels just fell off. First time that's ever happened. Never had the labels all just decide to pop off. Annoying fashion imaginable. Alright, we'll deal with these in a minute. I can avoid making a mess of everything between here and there. That'd be stupendous. Alright, so 65 or 62.5 is going to get in there, but also we're going to make 10x dilution. I'm going to just use one pipette. It's going all the way down. This is stupid. Alright. So 20 microliters. There's 20 microliters of that. Microliters of solvent into that one. And then I'm just going to suck up every last drop out of here. Alright, whatever that amount was. Okay, so now this is the 62.5, and this is the 6.25. This is 62.5. I can't write for some reason. All right, so those will go back on the Vortex mixer. So the next thing that we are going to do I don't know what the hell those were in those. So the next thing we're going to do is now we're going to dilute all of our samples so they can go into the auto sampler. Now the flower sample is the only one of them that will only be a 10x. The rest of them will be a 20x. That just is the dilution factor. So I'll grab these 20x stickers and slap them on here. Alright. Now we got these. Alright. So if you were following along from Wednesday, this is the reference standard from Wednesday. Unfortunately, at least half of it's evaporated out, so it can't be used anymore. Technically, only 2 injections have happened, so maybe you could say, okay, I'm gonna evaporate all the solvent out and then put back in whatever minus 2 microliters, but that's not accurate either, so we're just not gonna mess with it. 1, 2, 3, 4, 5, 10. Alright, so for all of these, except for the first one, it's going to be 950. The rest of them, it'll be, or for the first one, it's going to be 900 microliters because we're doing a 10x dilution. It's going to be 900 microliters of solvent, 100 microliters of solution to make a 10 times dilution. That'll be our flour. And then we're going to take 950 microliters of solvent plus 50 microliters of solution to create a 20x dilution for literally everybody else. So let's go ahead and get that going. All right, so what I'll do first is the solvent. So 900 microliters of solvent here, or ish. All right, there's 900 microliters into the first one. Adjusting this to 950 microliters. 2. Number 3. Number 4. And number 5. Alright, so that's the solvent for everybody, hopefully. And then the next thing we're going to do is actually take our solutions. So the first one's going to be flour. That's going to be 100 microliters out of there. And before I do that, I'm just going to give this a really good shake. Alright. There's 100 microliters from the first one. Discard our tip, grab the next vial. Hope they stay on while you grab the damn vials. Grab a new, fresh, clean tip. Reset to 50 so you don't screw up your dilutions. 50. Boingo, boingo, boingo. Boom. Alright. There's number 2. These fucking vials are killing me now. Number 2. Number 3. Okay. Number 3's in there. Number 4 is our hash sample. And then finally, number 5. Not sure what this was called. Looks like a hash kind of thing too. There's number 5. Boom, boom, boom. Alright, so there's that. Now we're going to put tops on all these, shake them up for a few minutes, and get going on the testing part. Make sure these are all nice and tight. Don't want no accidents happening on our watch. They do. Okay. So those are running. Now what we're going to do is switch over to the computer. And we'll start to actually key in all these entries, the calibrations, and then also, these samples, we'll get those entered too. Let's see what we can do over here. Need more space. Fuck everything up. It's cool. Don't worry. All right. Flour. So 9.4613. Call that hash 39.1. It's going to be 25.5 and 9.3695. Okay. Save sequence. Alright, so it's going to run now. Alright, so now auto sampler is running. Boingo. Just popped in the very first calibration, and now what I want to see here, let's see, would be on the next 33 minutes, hoping to see 3 injections to where the linearity, I guess, is consistent. Shall return. All right. So, first run is done. It just finished. Now it's a waiting game, unfortunately. So if you're watching, it now occurs to me that I did not, looking at the chromatogram that just came through, it occurs to me that I did not add the internal standard to these injections. Which means there'll be no control. So I'm going to have to redo it. Got to abort the run. Pull that stupid shit. Alright, so we already ran one injection off of the 125, which means we don't know exactly how much is in there, which means it's simpler to simply produce a new vial. We're just going through vials and vials today. All right, so we need three new fucking vials. 1, 2, and 3. All right. We will need to get inserts for all 3. Insert 1, 2. All right, there's 3. So now I'm going to, using my mechanical pipette, take 100 microliters from each of these, if I can, and put it into the new vial. It's not always the most easy thing to do because these are inserts. Sometimes these inserts will not, like this. So I can't, fuck me. So I can't pull this out because I can't get my pipette tipped to it. Hey, it's a day. Only thing I have that might get in there is a needle. just had to go find a needle. This, by the way, defeats the whole point of what I was trying to do. You know, today is being a frustrating day. Put it that way. How are you supposed to get anything out of there? I don't think there's 100 microliters. I can't even get an accurate amount of how much fucking standards in here. Man, this sucks. Well, shit. This does not look like 800 microliters. Ugh. Oh shit. So annoying. Oh, this really sucks. Alright. Unfortunately, I have to open up the standard again, but even more unfortunate than that is we're down to the last bits of it, which really sucks. And it means I'm going to have to be really, really precise about how I do this last bits. So there won't be room for fucking up. So, one thing I need to do for certain is extract 100 microliters from the standard and evaporate it out so that I can replace it with my solution. So frustrating. Frustrating. It's all very frustrating. Alright. Alright. There goes nothing. "100 microliters. supposedly standard left. Alright, so 100 microliters of standard are now in this jar, which I have to evaporate the solution the standard's in out. Alright, so now we're going to dissolve away the acetone in our official ResTech standard. And while that's doing that, we're going to take our unofficial cannabinoid standard that we made last week, and I'm going to do a 200 times dilution. So I'm going to do a 200 times dilution, and I'm going to fill this 40 milliliter vial up with, I want to do it with the internal standard. I think we will do it with the internal standard. So I just got to figure out the math on this. So I want to do a 200 times dilution. I need 1 part to 200. Yeah. So if I put, let's see, 1 milliliter in there. So if I put half a milliliter, that'd be 80. So I put a quarter milliliter in there, and then 40. Be like 320, right? Let's do I want to dilute, so 100 was too much, or was not enough the last time. So now I want to do a 200x dilution. So that's like 1 in 1,000, right? Definitely braining that well today. So I want to do a 200x dilution. I want to get to 200x. the way that I'm going to do that. All right, so we're going to do 200 microliters, followed by basically 40 milliliters minus 200 microliters. So Alright. So now okay. Really? Okay. Let's just go ahead and get, we're going to take 40 milliliters out of here. This thing's fucking huge. Ten. $20. 30. 40. 40, by the way, is too many. Alright, so now we're going to take 200 out of here. And finally, 200 of our internal solution. Alright, so in theory, we now have 40 milliliters of standard that has been 200 times diluted. So now we're going to start testing that out. So we're going to get this mixed on the mixer, and then we're going to check on the internal ResTech standard for how well it's dissolved. Alright, so then the next thing we're going to do, let's see, I need to label that vial, so I should make a label. So the ResTech standard has evaporated. So this was 100 microliters of ResTech standard, which I think is packaged in Acentril. Anyway, so that's evaporated out now. So now we're going to add 800 microliters of solvent. Okay, so that's going to be 800 microliters of this stuff. Go ahead and... That's annoying. All right. So 800 microliters of acetone with internal standard added to the ResTech internal standard, which was 100 microliters. So now it's 100 diluted to 800, which makes for a 125 part per million. Is what this is now. So now I'm just going to vortex mix. Okay, so can't spell standard, but that's fine. No one will see it but me. I think now what I'm going to do is do a... Alright, so what I'm going to do is I'm going to wait till that's done. And then I'm just going to do the same series of dilutions to the standard I made, and then also to the ResTech standard. We're just going to do a simple 3-point. So we'll do 125 points, which is what it is natively now. And then we'll do, we'll cut that in half to 62.5. And then we'll dilute that one by 10. And then we'll get to testing. Alrighty, so that should be nice and mixed. Some of these out of my way. I'm going to label this as a 125 res Aztec. Alright, so that's 125 res. Just going to go ahead and here, pull out a milliliter out of this vial. And we're going to work off that milliliter. Very, 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 very full. Alright, so 1 milliliter there. Alright. So now so I didn't dilute, I did not remove the solvent from my standard when I made the 40 milliliters of it. And all that means is the internal standard will be off by 1/200th. And I think that's more than acceptable, considering that's 2%. That's what, 0.5%. 0.5% variance, I'm okay with that. Alright, 125 mine. Alright, so I have 125 part per million solution in both, well, in the Restec standard. I don't know what mine is. I wrote 125 because I was on autopilot. So clearly that's not accurate. But either way, it's a 3-point, or we're going to make a 3-point series. So I've got 6 vials in this thing. I'm going to make 3 points with the Restec standard. Then I'm going to make the exact same 3 points with the standard I made. And then we're going to run them all. That's probably going to be it for today. After all that's done. Alright, so now the great thing about my standard is I already have the internals part of it. So I'm just going to go ahead and take 200 milliliters out of the 125. So this is the fuck up I did last time. In order to make the 60, so maybe I'll just do 10. So instead of doing a 10x dilution on the 60 to create a 6.2, I'm going to do a 10x on the 12.5 to create a 1.25. And the reason I'm going to do that is simplicity. So I can take 10 microliters out of the 125, put that into the third vial, and then I can take 50 out, and then add 50 into the second vial, and then add the solvent back in. And then I think that'll be a lot easier. So the first one I'm going to do, I'm going to start with my standard first. And I'm going to take from that 10 microliters. I'm going to set my thing first. All right, 10 microliters. I'm going to open my jar of solvent. I'm going to turn off this fan here. I do not need it screwing with me. All right, so I'm going for mine. Boom, boom, boom. I believe that's correct. 10. All right, 10 into there. Now I'm just going to go back up to 100. This is what I'm going to put into each of the other two. Then we'll move on to the solvent. All right, so now I need 90 microliters of solvent. For the first vial. Okay, there's 90. And then I'm going to do 100 into the second vial and nothing for the third. All right. And that's going to be that. Now I'll get lids, cap these guys up. All right. So now that those are done, what I've done is just gone ahead and label them as 1, 1/2, and 1/10. That's those are the strengths. Now, I'm going to do the same thing again, but this time with the ResTech standard. So again, going to go all the way down to 10 microliters. Going to go 10, 50, and then 10, 50, and then 100. To do our dilutions here off of the 125 premix. So these already have what you call it, the internal standard is applied. So there's the 10. Moving now to 50. Or excuse me, now I'm just moving to 100. Under there. Under there. Close off the standard. Now, 90 for the solvent on the first one. And then back to 100 for the second one, nothing for the third. There's 90. And there's 100. Okay. That's the end of those. All right. So now we should have, after they get mixed and homogenized, a 125 part per million standard. We should have a half, 62.5. 62.5. And then this should be 1.25. All right. So the standards I made are in green, and the standards from ResTech are in black. Okay, so now that that's done, all right, so now that that's done, I'm going to go into the computer. Go into the computer and add our 3 calibration points from our standard, and then we're going to update what we had as well. So copy 1, 2, 3. So, in fact, let's start. Let's see, 6.25. Okay. Okay. So now, sequence table. Hold on. So now we're running the sequence. This machine will start to grab the vials and go from there. And now it's a whole lot of sit and wait, unfortunately. So I'm gonna put my standards I made away in the freezer. And then as soon as the ResTech standards are finished running, I'm going to pull them out of the auto sampler, put them back in the freezer too, so I can try to use them again for as long as I can. But the other thing that I'm doing now too is I'm running the cannabinoid standard mix that I made, and we'll quantify that against the standard from ResTech, and that'll allow us to use that as a standard going forward. Yeah, if you're watching this, I can't see you comment, so I'm sorry. I've been talking to myself this whole time, as far as I know. The white carafe. No, no worries. Cut the big part out. Yeah, I'm so sorry, guys. The StreamYard that I get to see on my side doesn't show anything. I don't know why that is, but if you've been commenting, I've not been seeing it, and I apologize. I wonder what those were. Some late spikes coming through on the ResTech standard. Well, I can't see. I can't see who all of you is interacting with me, but let me see if I can bring this page into StreamYard so you can at least see what's going on. Let me see what I can do. All right, we'll see. Yep, enter. Oh, look at that. Comments finally just came through. You can't blame chat for the standard. That's probably true. Free girls in your city. Well, thanks for the comment on YouTube. Hey, at least getting some comments on YouTube, even if they are only spam. All right, that guy's gone. All right, so the lab PC, GC, PC, whatever. Boing. Present, share screen, window. All right. Now we're cooking with Crisco almost. Let's see about this one. Add to stream. Heyo. All right. So that's something. Let's see, what do we got to do to make this look better? All right, that's a little better. So that's StreamYard. Okay. So if you're following along, although I can't show you my mouse, I can move this thing. So these peaks starting all the way over here at the far left. This is the internal standard, followed by CBDV, THCV, and then I want to say CBL, CBC, CBD, D8, D9, CBG, CBN. I can't remember exactly. Yeah, if they're going to spam, they could at least hit the thumbs up. I agree. I don't know if anyone's even seen the stream on anywhere else. In fact, I didn't know anyone was watching until 4 minutes ago when I looked at my phone and saw people were commenting and not showing up here. That's okay, though, because I've just been a crazy person talking to myself for the last couple hours. Anyway, so these are the peaks from the standard. What's interesting to me is these peaks right here, well, they shouldn't really be there. So it's unknown what the hell those are. Because the last cannabinoid in the standard on my method comes out right here at 2 minutes, 2.71 minutes, roughly speaking. That's CBN, again at 2.7, so who knows. What's in the machine? So Old Scratch, just looking at, again, I apologize, I didn't get some of these comments as they were coming in, so I'm not sure. It's a matter of matching what's in the machine. I'm not sure what this is referring to, but if you want to hit me up in the comments, I'll be happy to re-answer that. Life juice, yeah. Speaking of which, Cosmo. So, again, I don't have any decaf made up, and I got to make that up probably tomorrow. So yours hasn't gone out yet, but it will very soon. Very, very soon, I promise you that. So yeah, this is a lot of sitting around waiting, which is really unfortunate. And also what sucks too, so like right now, all we're waiting for is for the machine to just stabilize again. And that's kind of what this hump here at the very last part of this is. This is as the temperature goes up, the signal kind of goes up too. This is when we stopped. This is when the program ends, basically. It doesn't get any hotter in the oven. And then as it starts to cool down, the signal correlates kind of like with the temperature. So what we're waiting for here is for this just to get back to a steady baseline so it can run again and be as even keel as possible. So it takes 4 minutes to actually run the injection through the gas chromatograph, but it takes 11 minutes before, well, back to start to end, it takes about 11 minutes for this thing to run at all. So, or run one run at a time. So now that's what we're going to get to see here. And I was thinking, let me see if I can unplug this. I was thinking, since it might be kind of cool, I was thinking maybe we should put like a camera somewhere around here so you could actually watch as this thing does its thing. Not that it's super interesting, but you know, it's probably more interesting than staring at me. At least occasionally. So that just dropped off the vial in the that just dropped off the vial into the auto sampler. Now it's gonna take some pumps out of it and blast it through the GC. And then as soon as this thing injects, we will see on the computer a line come through, and then we'll start to see peaks. So there's the injection. So now if we're watching the computer screen, we should start to see lines. Basically, as the gas chromatograph runs, we'll see the signal response. So the very first thing you're going to see is the solvent peak, which is always very large, or generally very large. And then depending on what you're running, so if we were running a cannabis flower sample with lots of volatiles, for example, then you would typically see lots of little peaks right up at front as well, because those volatiles will be the first thing to come out. So unfortunately, with the column that I use, it's not selective enough on the terpenes to actually separate them sufficiently for resolution, and that would require basically a whole nother column for that. So it is possible to do a single method that runs cannabis and terpenes. I don't have the column for that, unfortunately. And now it's done. So this peak that just came through, you'll always see it if you notice where it says elapsed at the top, 1.3 now. So that's just the time in the method, 1.3, 1.4. So the internal standard always comes out at 1.2 minutes. The first cannabinoid that we test for comes out at 1.8 minutes. And the last one comes out at 2.71 minutes, basically. And that's CBN. So now we just basically get a wait. So what I'm basically doing at this point, there's nothing really for me to do other than literally watch it. Does it require another machine to get the column? No, it does not. So Old Scratch, it does not require another machine or anything else like that. So in fact, I do have a terpene testing column. My iPad is currently sitting on top of the box that holds it. So basically, these are the columns. Okay. So this is a glass tube with silica and other media that's inside of it, pretty much. And then what this does is this goes into the machine. This one right here, it goes into the center thing right here in the middle. That's basically the oven. Anyway, so I do have a column for testing terpenes. Now here's the thing. It's already really ridiculously unprofitable to test cannabinoids. For any of those who were blindly watching along as I wasted what could only be $200 to $300 worth of internal standards, testing terpenes is even worse. So not only with the terpenes can I not make my own like faux standard, not as successfully. It takes 4 minutes, 5 minutes for this method to run, 11 minutes back to back. It takes over 40 something minutes for the terpene test to run. Okay, so that's 40 minutes just for that to run. And then I have to spend my time looking at basically what you see on the computer screen here and quantifying that and going through, okay, this is Delta 9 THC and this is how much, this is that, etc. So all that's done manually. And yeah, that sucks. It takes a long time just to do it for 9 cannabinoids, let alone for, we should be able to resolve well over 40 plus terpenes on the terpene method. I really have no idea what these 3 peaks that come after the others are. That is bizarre. But we saw it on the last injection too. So whatever it is, it's probably a contamination in the solvent, if I had to guess. So 1 column per THC test and used up. So we use the column. The column can be run hundreds of times, generally speaking. The standards get used up. So every time I run this, I have to run a standard with it. If I don't run a standard with it, basically the machine is so sensitive that background pollution can, affect its signal quality. So I have to run a standard with it so that we know, basically so that we can like take the background noise out of the equation, more or less. Now you could do it without running a standard at the same time, but it won't be as accurate at the end of the day. So we want to run a calibration, or at least a couple calibration points every time we run one of these, so that we are using, or so that we're measuring, at least as reasonably accurate as it possibly can be. But basically all the column does, so the gas chromatograph, right? So gas, it vaporizes the sample. And then when the sample gets vaporized, it goes through that column I just showed you. The media that's inside of that column slows the compounds down like resistance, essentially, okay? Polarity and resistance. So as the gases go through, it meets more and more resistance depending on basically the compound. More resistance means the more time it takes for it to come out of that column. The time that it comes out of the column, so for example, 1.2 minutes or 2.4 minutes or whatever it is, that's called the retention time. And the retention time is how you identify what when, basically. And then it gets a lot more complex from that. But for our purposes, retention time lets you know when it comes out, and then the gas chromatograph measures the amount of signal when it burns that compound coming out. So it's vaporized into a gas, but then it actually gets burned by a flame, which you can't see, but there's a flame on here, and that basically burns the compound, and the detector measures how many ions come out when you light it on fire, more or less. So the amount of ions that come out is the information we use along with a standard to then correlate that to a quantification or a known amount, basically. So again, a whole lot of this is just sitting around waiting, which is unfortunate. One thing we can take a look at here, it's pretty easy to see. This is the same injection, by the way, same vial that ran. First is the first injection, and then the second one is the second injection. And you can see just how dramatically different the response on the signal was, right? That's where these are here on this injection but they're way up here over on this injection. So if you were watching when I screwed up, the reason I had to go back and redo the calibration standard is because I did not include the internal standard. The internal standard, again, is this little peak that you see here at 1.2 minutes and right here at 1.2 minutes. The internal standard lets me know that the injections are consistent, basically consistent, right? In this case, if I were to look at this and, I look at, this is the first calibration run, and if I had an injection that looked like the first injection, but every other injection after looked like this one on the right-hand side, then my data is going to be really bad, So the internal standard allows me to know how much compound was injected relative to the internal standard so that I can use that internal standard against every injection after to normalize the values. And that's what the internal standard is ultimately used for normalizing. So the question is, do I know or the computer know what compound burns and at what time temp? So basically, and I'll show you, I'll go ahead and show you this once they're all done running. But I have to go in and then mark down calibrations. So I'll have these 3 calibration points. The next one, it sounds like, is about to run. So I'll have 3 calibration points, and then I go into the software, essentially, and I say, okay, over here, this peak is CBDV, and because I used the standard, I know that correlates to 125 parts per million. So CBDV at 125 parts per million, or close to it based on how imprecise the injection is, generated this much signal response. That's where you see kind of like that 700 on the left-hand side. So this is signal response. And then I go into the software, and then I'm basically going to say, this is CBDV, this is how much, blah, blah, blah. And then I'll do that for each level. And then it will know, and it'll be able to generate a report for me. However, the reports are annoying for twofold reasons. 2 reasons. One, the software is so damn old, it's just fucking ugly. And it's really hard to make it work right. And then, all right. That's a great question, Old Scratch. Could you figure out what the 3 unusual readings are? So that's a really, really, really good question. Looking at this here, before it disappears on me, like, yeah, what are these? That would be awesome to know. This is why. So, to answer your question, if you were taking this from like a research perspective, and you were going to go, okay, what are these compounds? What am I looking at? Or maybe you're just reverse engineering it. You wouldn't use what I'm using, which is a flame ionization detector. Okay, so that's called an FID, flame ionization detector. And that's really, it's a good tool for what it does. But the downside to it is it measures based on ions, and it's indiscriminate basically. So the downside to it is, in order to know what compound that comes out of there, you basically have to have a pre-established method and go through and follow that pre-established method, run it, and all that kind of stuff. Now, if you're trying to find out, like, what is this compound, the thing that you would be doing is you'd be running it through a mass spectrometer, and you'd probably be running it through what's called a GC by GC. So a GC by GC is, so the column that I took out and I showed you, that has one set of polarity. A GC by GC uses 2 of those columns back to back, but they have separate polarities. So the first column slows down compounds of a certain polarity, And then the second column slows down compounds of a separate polarity or different polarity. And the result of that is compounds come out really, 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 really slow and more so individually. So you get really good separation. But then you're going to feed that into a mass spectrometer, which can tell you, basically the mass of the ions, the mass of what just came out. And then you can use some of that information to identify the compound, right? So there are libraries out there that have compound data in it, and you can kind of use that to look it up. It's not the end all be all because there's a lot of compounds that share molecular weights and things of that nature, but it is how you would get the process started, and you would probably run it through a mass spec to try to find out what that is. Based on the weight of things, you might use your intuition to further try to isolate down, but that's how it goes essentially. If you want to find out what something is, you got to throw compounds at the GC and wait for it to come out at the same time, and then hope that is what you're looking at. So I'll give you another example. So everyone's familiar with Delta 9 THC, maybe even the other ones like Delta 8 or CBG or CBD, stuff like that. But a lot of the other cannabinoids people are not familiar with. See, there's those 3 peaks again. It's fucking weird. It's in the solvent. Whatever it is, it's in the solvent. Anyway, so I forgot where I was going with that. But if you're gonna find out what something is, you're gonna run it through the mass spec. You're gonna identify it by its weight, and then start throwing things at it until they come out at the second time. Oh, which brings me to the other point. So the other things, folks don't know about for cannabinoids are things called exo and isos. And you don't generally see these, like these are not cannabinoids that are prominent in the plant. You'll mostly see them in plant that's been treated with, there's some fire retarding agents that contain sulfur and similar type compounds, which basically can isomeritize the cannabinoids that are in there. So anyway, on the FID, what you cannot see here would be the isos and the exos because they elute to come out of the column at the same time. So in that sense, even when I run my method, you're not going to get separation on those compounds. Now, that doesn't really matter for 99% of the testing that I do, because the testing that I do is for, it's generally something you grew yourself or processed yourself. So you kind of know about how it's been treated. So it's not a big concern from my perspective, but in research labs where you're looking at cannabinoids and you might be looking at things like, okay, I need to separate out or know how much exo THC versus iso THC of this cannabinoid or another, then you're going to be looking at a mass spectrometer for that. That's going to get a lot better resolution. And we do have one here at the lab, but it is not hooked up. It's way there in the corner. And it's not hooked up because, like everything else in a cannabis lab, it is extraordinarily freaking expensive to turn the damn thing on. So it is not hooked up at this point in time, and we are running the FID, which I think is going to be running here in another minute. We only have Delta 8, Delta 10 TCO here in Kansas. Yeah. So Delta 8, Delta 10 THCO, if you're not familiar, all of these are synthetic cannabinoids. They've all been identified in the plant at one point in time, and there's reasons for why that is. Basically sunlight, UV exposure, chemical exposure can isomeritize, can chemically change the cannabinoids that we see into these other ones. So we don't see Delta 8 or Delta 10 when testing flower, generally speaking. It's generally nothing there. And the few exceptions to that seems to be more so on outdoor flower that's probably been treated with something because it's outside and then exposed to sunlight. But yeah, so Delta 8, Delta 10, THCO, those are great cannabinoids. They're still relatively new. Delta 8 is probably the most well studied. And if you didn't know, so Delta 8 is pretty cool. It's not as psychoactive as Delta 9, which, I guess if you're trying to get high, then that's a bummer. But otherwise, it's actually really useful medicinally. So Delta 8's got pretty good body properties without being overly intoxicating. But Delta 8 is in particular really useful for nausea and nausea-related conditions. They did a study in Israel. In fact, a lot of the studies on cannabinoids you'll find if you go and check into the research, a lot of those studies are in the past have been done in Israel. So shout out to them for continuing on the research. But anyway, so there's a couple studies out of Israel where they used Delta 8 and they used it on, I don't remember if they were suffering from cancer or not, but they needed help with their nausea. Children needed help with their nausea, so they gave Delta 8 to children, and it helped eliminate all the nausea without all the adverse side effects of some of the other medications. So that's really cool. So Delta 8's a really good one. It's also pretty good for pain. Don't know a whole lot about Delta 10 because there's not a whole lot of research into Delta 10, at least not to date. And then same thing with THCO. So if you're not familiar with THCO, that's basically acetylated cannabinoids. And if the word acetylated sounds at all familiar to you, it's probably because aspirin. So aspirin is acetylated, and the reason aspirin is acetylated is so that your liver doesn't destroy all the aspirin before it gets to your body to do some good. So similar to cannabis, aspirin, right? Your body goes through a lot of work to reject whatever you take in that way. So by acetylating it, you're turning it into another compound. The liver doesn't interact with it, nor do the liver enzymes that would typically interact, or the CYP450 enzymes that would typically interact with THC. But there's another enzyme in the body that strips off the acetate part of the molecule, and then you just end up with D9. So that takes like 40, 50 minutes after it's in your body for that process to run. So, if you're smoking, you probably don't notice it right away. You probably notice it about 50 minutes later. And if you're taking edibles, probably roughly the same thing. Yeah, so D8 flower, if you don't know, nothing wrong with it. It's just hemp flower that's been sprayed with Delta 8. And how they do that can or cannot, could be a bad thing, because distillate's not very flowable. So most people are going to dissolve it in the solvent and then spray it on as in a solvent and then wait for that solvent to evaporate, which not ideal either. But yeah, I mean, it's certainly a good option for. I don't have any problem with it if it does what you need to do. That's all that really matters. But my main thing is to make sure you know what it is. I don't think the plant is the perfect end all be all for its medicinal value. I like to view the plant kind of like a random number generator, and it randomly generates terpenes and cannabinoids and phytocannabinoids and all kinds of other stuff we don't know about or can't measure. So I like to think of it in that term, and I like to look at its constituents and what it makes for their usefulness individually. So it doesn't bother me to say, hey, if D8's what does it for you, if that's what treats your nausea, your pain, your whatever, cool. And that might actually be better than Delta 9, right? But I think that all comes down to your own personal view on whether or not it's plant-made versus plant-inspired, which is what a lot of these cannabinoids are, right? So D10, D8, D9, they're all converted, D9 and THCO in particular, they're all converted from CBD, right? That's what makes Delta 8 is you take CBD and a strong acid. That acid closes the ring and makes Delta 8 or Delta 9, depending on how that ring closed. Which is cool, because that's why we now have so cheap access to cannabinoids these days. It's because a lot of them are created from CBD hemp, which can be grown, acres and acres and acres at a time. So if you're following along, we're at 1.2 minutes. The peak that just came through is the internal standard. This is, I want to say run number 3. So hopefully it's the last of the, can't tell. Hopefully it's the last of the calibrations. It looks like it will be. Which is good. So once this finishes, I've still got about 2+ hours of this thing just running. So I'm not going to sit around and wait for it. I think I'm going to let these run, and then I'm going to pull them off of here, put them in the freezer. I can already tell you I might have to redo some work on this. This just does not look like it diluted the way I would expect it to. So we shall see. We shall see indeed. Basically what I'd be expecting here is to see like this middle one as it is, this one slightly less, and then almost like this one on the left. But instead, they're all very similar to one another. So this might as well be the same run. But it looks like it could be the same as this. It's not even 20% off. So I don't know. I'm going to let these run, then I got to look at the data. That's going to take a couple hours. And then, yeah. So I don't think I'm going to sit here in front of this just waiting anymore. If y'all have any questions, I'm happy to answer them. But otherwise, I think we'll wrap up here pretty quick. See ya, Cosmo. Thanks for taking the time out of your day, brother. There's these weird 3 peaks, every single one of them. So bizarre. It's strange too. It's really, really strange. Because whatever it is heavier than the cannabinoids. I don't know where they came from or what they are. But they're definitely in there. All right. It was good talking to you, Old Scratch. Thanks for stopping by. And anyone else who's listening, hopefully tomorrow, I'll be back in the lab tomorrow. And let's see. Hopefully tomorrow the comments will be working correctly and I'll be able to see that from the beginning. And then I think tomorrow, if this is done, and the only reason it's not going to be done is if there's some dilution fuck up somewhere. So if this is done tomorrow, I think what I'll end up doing is making a standard in ethyl acetate, which is what we'll use for testing edibles. So maybe that'll be tomorrow. Not sure. But thanks everybody who did stop in. Really appreciate all you. And I think we'll catch up tomorrow probably around 9 a.m. Arizona time. So that's mountain time. And we'll see you then. Peace out.